there's another problem we looked at today where we have a meter stick with a weight hanging from the end and a line holding the meter stick from pivoting along these lines. My question is, what is the tension in this line? And it's hopefully something we're going to do tomorrow. I'll have a scale in between here, and you've got to pretty much predict what that tension is going to be. Prior knowledge here is the bar is equal to 80 grams. In other words, the meter stick is equal to 80 grams. Where is its center of mass? The bar is behaving like all the mass is concentrated there. Again, you have to be able to get through this. The bar is acting like it's a torque right here. Then the ball or the mass hanging, let's call it 120 grams. It's 100 centimeters down the ruler. Now I can change these things. I can move the ball here, I can move the string here, I can move the string here, whatever. But pretty much the center of mass of the meter stick is always going to remain at the 50 centimeter mark. Let's see how we solve for tension. That is, what's the force pulling this way? The force, not the torque. What's the force pulling this way? It's a torque problem, so let's look at all the torques. We have a torque due to the ruler. The ruler wants to slide this way, so there's a force of the string holding it up. The ruler, if we were to cut the string, would pivot this way because of the mass of the ruler itself and because of the weight. Well, what's holding the ruler from spinning downwards? The string pulling up in that direction. Don't forget that torque is always force perpendicular times the radius. This is what I mean by perpendicular. We cannot look at the torque caused by that string in this 30-degree direction, 35-degree direction. We have to break into its component parts. So we'll have a component part in this direction and a component part in that direction. The forces will. But we'll deal with that later. So how do we set this up? The torque total is equal to torque 1 plus torque 2 plus torque 3 and torque 4, which is the string. Now you know if this is going to be the pivot point, that torque is going to be 0. Sorry, the whole thing's not moving. The torque is 0. Torque 1 is going to be 0 because the radius is 0. Again, the whole thing is not moving, so the total torque is 0 since there's no motion. And the torque at the pivot point, since its radius is 0, it's going to be 0. Now this torque, this might have a force. The force might be high, but since it's the pivot point, it's 0. Torque is, once again, due to gravity at the 50 centimeter mark. Torque 3 at the 100 centimeter mark, and that is due to the mass times gravity of the weight itself. And this is the torque 4 upward. What is torque equal to? Torque is equal to force times radius. Now force 1, radius 1 is going to be 0. Force 2, radius 2. Do we have the force? We have 80 grams times 9.8 meters per second squared. That will give us our force. Do we have the radius? 50 centimeters. So we have both of these. How about the torque due to the ball? Do we have the force due to the ball? It's 120 grams times 9.8 meters per second squared. Yes, we have the force of the ball. Do we have the radius of the ball? Yes, it's 100 centimeter mark. Do we have the force of this string, even in the y direction? No, we don't. Do we have the radius of the string? Yes, it's at 100 centimeters, so we know everything except force 4. I drew it all out, and I put the check marks above it so you can see what's going on. Now if we look, I've rearranged it. I've taken radius, and I've divided the radius out. It comes over here. Here's our equation. Let me simplify it here. Force 2, yes. Radius 2, yes. Force 3, yes. Radius 3, yes. Force 4, we don't know, but we do know the radius, so the equation is ready to go. All you have to do is supplement the numbers in that we looked at before. Only problem is, it gives us this force. You'll find this force here. So how do you find, once again, that's force 4. But we want the tension in the string. So if this is 35 degrees, what does that got to equal? Remember, the total sum is going to be 90 degrees, so that's got to be 55 degrees, right? 55 here. And we don't know that, but if you know this, and you know this angle, using SOHCAHTOA, you can find the hypotenuse. So I'm going to let you use SOHCAHTOA and figure that out for yourself.